How can we use this? Well, if you're asked to find how many points of intersection there are between the parabola y equals 2x squared minus x plus 1, which we're going to call equation 1, and the line 2y plus 6x equals 2, which we're going to call equation 2. One way of solving this is using simultaneous equations, as before. So we're going to take equation 2 and we're going to rearrange it into y equals, so we can substitute it in. So 2y is 1 minus 6x. So y is going to be 1 minus 6x over 2. Now if you substitute this in equation 1, you're going to get 1 minus 6x over 2 is equal to 2x squared minus x plus 1. And to get rid of the fraction, we need to multiply both sides by 2. So we're going to get 1 minus 6x, and remember we have to multiply every term on this side. So we get 4x squared minus 2x plus 1. Now as it's a quadratic, we get everything equal to 0. So 4x squared, now minus 2x plus 6x is going to be plus 4x equals 0, because the 1's are going to cancel 1 minus 1. So 4x squared plus 4x equals 0. Now to find out how many points of intersection there are, we need to substitute it into b squared minus 4ac. So in this case, a is 4, b is 4, and c is 0. So b squared minus 4ac becomes 4 squared minus 4 times 4 times 0. So that's going to equal 16. So as b squared minus 4ac is greater than 0, there are 2 points of intersection. Another example, we might be asked to prove that y equals 2 minus x is a tangent to the curve x squared plus y squared equals 2. So we're going to call that equation 2. Now, at the point 1, 1. Now what we're going to do is substitute equation 1 into equation 2. So now we get x squared plus 2 minus x squared is equal to 2. If we expand the bracket out, we can have x squared plus 4, then we'll have minus 2x, so minus 4x plus x squared is equal to 2. Remembering a bracket squared is the bracket times the bracket. Now as this is a quadratic, we'll get it all equal to 0, so 2x squared minus 4x plus 2 equal to 0. Now, for it to be a tangent, b squared minus 4ac must equal 0. So, we have b is negative 4, a is 2, and c is 2. So if you substitute that in, you're going to have negative 4 in brackets squared minus 4 times 2 times 2. So that's going to give you 16 minus 4 2's are 8, 8 2's are 16. 16 minus 16 is equal to 0. Therefore, it's a tangent. In this example, we're asked to prove that y equals 2 minus x is a tangent to the circle x squared plus y squared equals 2 at the point 1, 1. So what we're going to do is we're going to substitute y equals 2 minus x into the equation of the circle. So that gives us x squared plus, now instead of y squared, we've got 2 minus x all squared is equal to 2. And remember, it's the bracket squared, not each term. So when we expand that out, you're going to get 4 minus 2x, which is minus 4x, plus x squared is equal to 2. Now we've got a quadratic, so we want to set everything equal to 0 and collect all the like terms. 4 minus 2 is 2 equals 0. Now, because we've got the 2 in front of the x squared, the first thing we should do is, can it divide into every number? And it can. So we're going to divide each term by 2. This gives us x squared minus 2x plus 1. Equals 0, and this will factorize to x minus 1 squared equals 0. Because because there's one real solution, we didn't need to use the b squared minus 4ac. Because the factorised bracket is one bracket, we know it must be a tangent. It touches but doesn't cross. And if it's a tangent when x equals 1, then y is 2 minus 1, so y equals 1. Okay, if we want to prove that y equals 4 minus x doesn't cut the circle, first thing we need to do is substitute y equals 4 minus x into the equation of the circle. So we get x squared plus 4 minus x squared is equal to 4. Now if we expand the bracket, remember it's the bracket squared, you're going to get 16 minus 4x, which is minus 8x, plus x squared is equal to 0. Equal to 4. Let's just correct that. Now, because it's a quadratic, we want to get it all equal to 0. So 2x squared minus 8x plus 12 is equal to 0. Now remember, whenever there's a number in front of the x squared, the first thing you should do is check to see whether it will divide into every term. And in this case it will, so we're going to divide by 2. This gives us x squared minus 4x plus 6 equals 0. Now, if it doesn't cut the circle, that means there's no real solutions. Therefore, b squared minus 4ac should be less than 0. So let's have a look. B squared is negative 4 squared. Don't forget the brackets. Minus 4 times 1 times 6. So this is 16 minus 24, which is negative 8. That is indeed less than 0. So there are no real solutions. So it can't cut the circle. Now if we want to find a, so that y equals 2x plus a intersects the curve, the parabola y equals x squared plus 3x plus 2 only once, just like before we need to substitute y equals 2x plus a in to the equation of the parabola. So 2x plus a is equal to x squared plus 3x plus 2. And again, make it all equal to 0. So x squared, now 3x minus 2x gives me x. And then we've got plus 2 minus a. Now for it to intersect only once, in other words it's a tangent, b squared minus 4ac must equal 0. Now in this case a is 1, because if there's no number it's a 1. B is also 1, and C is 2 minus A. So B squared minus 4AC becomes 1 squared minus 4 times 1 times 2 minus A. And we know it must equal 0 for there to be only one intersect. So 1 minus 4 2's are 8. And then negative 4 times negative a gives us positive 4a equals to 0. So minus 7 plus 4a equals 0. 4a equals 7. So a is equal to 4 over... Nope, got that wrong. A is equal to 7 over 4 for only one intersect.